Welcome to the Resairchia YouTube channel. My name is Jorge, and in this video we will continue developing our little Python GUI for running simulations. If you remember our work before the summer break, our GUI looked something like this. Now we will try to run bigger systems. For example, the case of a projectile, and ideally we would be able to declare the variables as in the initial altitude of the projectile and its initial velocity like this. However, as you can see, this doesn't work because we are not prepared for running bigger systems. I will explain the different changes we need to do to be able to run bigger systems. So, after making some changes, this is how the GUI looks like right now. You can see there's a new text box here that says Show FFT Analysis. I will show you an example with the Fast Fourier Transform for finding out frequencies and amplitudes. But first, I will come back to the example of the projectile. We used to have lambda t at the beginning like this, but now I'm including it in the code to simplify our system of equations. Again, we add our start and stop time and the time step. And we can simulate. As you can see, we have the classic shapes of projectiles that you can easily verify by using Newton's equations. I will come back to this example in future videos. Meanwhile, I will leave a very good reference in the description. Now I come back to the example that we have been used so far with the cosine. I have added some parameters to the values for our numerical integration. So when we simulate this case, we see a signal with some amplitude that we don't know and some frequency. The interesting thing is that now with the fast Fourier analysis, when we plot, we see our signal, we close the window, and then we see the fast Fourier analysis. Now here on the x-axis we have the frequencies, and on the y-axis we have the amplitudes. If we zoom over here, we see that we have a frequency of 5 Hz and an amplitude a bit above 0.125. The amplitude is actually this value. Remember, we are doing numerical integration, so if you don't see where this value is coming from, I will show you with this little explanation for integration. The whole idea of these videos is to learn and understand things properly.
So, we want to integrate this function. For this original function, we can perform a change of variable. And these are the steps that you need to follow to do so. Then we change our variable and we integrate. And then we undo our change of variable. So, from our original function, we can integrate it and obtain the new function plus the integration constant.
So, now that you have seen the explanation for these values, let me try to show you something a bit more complex. Imagine that instead of this easy signal, you have something a bit more complex, like a combination of cosines with different amplitudes and frequencies. The cool thing of the fast Fourier analysis is that from a weird looking signal like this one, you can obtain the frequencies and amplitudes hidden behind it. So, what did I do? First, when I click on the variable, If the checkbox for the Fast Fourier Transform is requested, we call this plotting function that will give us the Fast Fourier Transform results. I will leave a couple of links in the description as well, where you can read about the Fast Fourier Transform. They will explain it way better than me. Then I have changed the simulate function a little bit. First, I have moved the simulation setup to the beginning just to be sure that the code doesn't get confused. Now, to be able to declare several variables, I'm splitting using commas and again continue with the regular expressions. As you can see, it's actually very easy. I just take the array of variables and insert them in the box. The next part is I add the initialization, where I take the initial values for each variable and I store them in this array called xInit. As I said in the demonstration, I have added lambda t to the code, so you can skip that part. Now, the part that runs the simulation, I have added over here the time step to the stop time, so we are sure that we stop exactly at the time we mark. We evaluate the initial values array and then we populate the list of results. The checkbox is very easy to add and the code is over here. Now you can run different systems and see what happens with them. For example, this one. In the next video, I will try to show you how to make this Python code become an executable so you can run it and install it in any Windows computer. It is not very advanced at the moment. I still need to correct bugs and so on and check that everything works properly, but I think it will be very nice to be able to run this on any computer. Thank you so much for watching and see you in future videos.